G'day guys. I'm going to tell you, this will be the third video that I've made, and the first one I gave out way too much information, and the second one I gave out way too much information, and this one I'm going to cut it right back, because what happens is that you want to give you guys some education on stuff to do, but I think I gave away the whole shooting match on the first one, and I just don't want to do that, because I will be doing the usual in my own nest. Some of the stuff I went in way too much detail, way too much, and we'll let people like, I'm not going to tell people or anyone what is wrong with something they've made, or how to fix something that they've made. Basically, what I'm saying is, there's a lot of obvious stuff. There really is, to me anyway. And I just said, oh, no. And I'll always put the disclaimer there. In my opinion, in my opinion, I would not have done that. I would not have gone anywhere near using that device or those devices, or I would have done that in a different way. Only because I know I've been doing this stuff for freaking years. So has other people. But I think what they have is they have a change of guard in the design of some of this stuff, and no one keeps on top of it. What other people have discovered, and it just goes back in there again. It's we'll use this thing as an example, this 6000, but I'm not going to go into too much detail. We all know that these things had a problem when they came out. Okay, the 6000 had a problem with that howling, well, what people called microphonic feedback. And I actually thought to myself, well, how is this actually occurring? And we know they changed the inductors. I've changed the inductors here as well. They did have some of these blocky ones. I'm going to give away a bit of info, because this will explain why things happened and whatever. There's the inductors that were there. That's out of the factory. They're just I know they got big ends on them, and big soldering pads on the end of them, and the wire on these is wound as a the way they're sitting, they're wound as a horizontal spiral. It's round and round and round. And battery's alive. It just dropped its wires down there. Okay, well, what happens? I'll quickly do an explanation. These sit on the board. I'll just reconfigure them up. They sit there like that. That's them there. I just stuck them on there. If I tilt it, they're going to fall off. But what happens with these things, with these inductors, they're I'd say that black stuff is some attempt or some type of shielding on the wires. But the thing is, it's not shielded on the ends, right? It's metal plates, and it's not going to do anything to a magnetic field. Anyway, what happens? We got these sitting where these ones, well, that's where they were. They were there. I've removed them. That's them. And what they do is they radiate out this way and that way. So I'd say the flux, not the flux you use in soldering, but the magnetic or electromagnetic flux, which would have radiated out straight across that device there, which is it's a digital to analog converter chip, which is for the audio, by the way. And that could have been the issue there. It could have been just back and forth. It might not have been anything to do with the speaker itself. I can't. Well, I haven't proved it. I could prove it, but I don't really want to waste my time proving it, because it doesn't serve any purpose. We know how to cure it. I know how to cure it, and so do they, because they cured it. They reworked the boards, didn't they? So what I've done, and I've done mine in this way, I think they've done it the same because they've used flat type inductors here, and I've used flat type as well. These are nice little small inductors. I've tested this, works beautifully. Now there's no feedback issues. Now the planar types, which is flat wound, not like what was there, the field or the electromagnetic flux from the inductor on these goes up and down. It does not run off and power through that poor old DAC there or anything else. Whatever was going on, these are lower profile, closer to the ground plane on circuit board. Everything's a much tighter package. Being close to the ground plane does help as well with stray fields, and not having it aiming through the devices is a better idea overall. And because they put planar ones in there, I just did the same. I don't know the value of the ones they put in. I had a look at this, and I put 10 microhenries in there. Works beautifully. It actually might sound a little bit better, but it's subjective, and it's just my opinion. So that's the way to cure that. As you can see, that's what it is. Now, because of this inductor problem or issue that was there, it's not a problem, it's an issue. Call it an issue because as soon as you plug in a different speaker, external or headphones, it went away. Or so we believe. But I will say this. When you plug in headphones, these are not in circuit anymore. These deactivate. And what I mean is, I thought that was a DAC chip. It's not. Well, it is. I have to explain myself here. It is a DAC, but it's got a Class D amplifier built into it. A single channel Class D amplifier. And I'm going to say this because it's obvious to me, and it's my opinion. No one in their right mind should put a Class D amplifier in a metal detector and on the circuit board or anywhere near it. I mean, it's miles away. It's my opinion. I'm allowed to have this opinion, right? I know people won't like it, but tough luck, right? Because a Class D amplifier that utilizes these inductors here, will, because it's getting fed with pulse modulated signals, basically square waves that are all over the shop, it's going to cause all sorts of funny radiation, and it will. It's just the way they work. So they've done it for efficiency, and it's a good all-round chip because it's got low-level line level outputs. It's a stereo chip, by the way, and it's got a lot of interfacing. What else has it got in it? It's got I2C control line. It does all the sound bip bops and everything else. It's got pop suppression built in. It's got built-in attenuators on the audio lines. Got a lot of little knickknacks in that chip, so it's a good chip for that reason. But yeah, soon as I looked at the specs online, it's a Linear Technologies device, and I looked at it, I said, okay, it's a DAC, right? Okay, and then it's a plus Class D amplifier, and I went, oh, holy moly, right? And that is why I had to laugh because I got caught out with this myself around about 15 years ago, maybe somewhere 15 or 14 years ago. What I did, I made up the boosters. I was making up very efficient boosters. I'll just put that back down. And what happened? I was making up these boosters. I think I can't remember what we call them. Oh, LT booster. I don't know if any of you poor buggers ever got one. Right? I didn't make that many because I quickly stopped making them. And the reason was I thought I was going to be a smarty pants and make it super efficient and run on a multitude of voltages. And I actually put a Class D amplifier inside my booster. And these were the boosters that had the digital voltage display, so it told you how much volts are in your battery and stuff as well. Anyway, cut a long story short, I made these up and I put it on the detector, and I used to Velcro it onto the side of the detector, and can't even remember what detector it was. It was probably an old, GPX Stream or something. I don't know. Could have even been an SD. But when I put my booster on the detector, uh, when I turned it on, I was out in the goldfields and it was going like a woo, 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 and all this sort of horrible noise. I'm going, what the hell? I'm near interference. So I ran away from where I was and I set up somewhere else, and the same noise was there. And I'm going, oh my God, what's going on here? Why is there all this interference? Now, I didn't twig to the Class D amplifier. I should have, because where I mounted it was right near the front end, beside it. Even the alloy shielding of the box didn't protect the front end from this stuff because you can't stop the field. It'll just get in. So anyway, what happened? I took the booster off. It's the only thing that was different, and I had a old DTAC booster, which is probably no longer made either, which had a Class AB amplifier in it, which is what you should do, right? And it had a device. I think it was either a 500 milliwatt or a 1.5 watt Class AB amplifier chip in their design, and I put that on. Bloody no interference, clean as a whistle. So there's me thinking, damn, I've outsmarted myself. I tried to make a high efficiency um, amplifier that'll drive anything you throw at it, speaker wise. It could actually put out 4 watts of power. It was didn't use much um, battery voltage. It had shutdown on it. Had all sorts of fancy stuff, and I thought it was going to be something that killed the pig. All it did is kill the ability to go detecting with it. So I quickly ran away from Class D amplifiers near metal detectors. I learnt my lesson. I've actually tried some. There are some that come out and they're called noiseless Class D amplifiers, right? And I'll tell you right now, no, they are not noiseless. You can't put them near a metal detector. So that's my experience and my opinion, right? And that's why I was very surprised to find one of those inside a metal detector mounted on the circuit board. Um, these are designed quite. I'm going to back things up a little bit. I'm not saying whoever designed it's a complete goose or anything like that. And they know what they're doing. They put it here. It's on the processor board. There's a little bit of signal processing up here. For chopping and chopping up multiplexing. I'll say multiplexing. I was going to keep it simple, chopping up the input waveforms and sampling, but it is multiplexing. And on the back here, there's your input module, which is all nicely um, put in a big block of resin or whatever, plastic resin. I don't know what it is. It's just my opinion. And anyway, that's that. There's the supply rails for it, plus or minus 5. Whatever, just whatever it is. Transmit stage down here, switch mode power supply. There's a few switch modes on this. There's a switch mode there, switch mode there, switch mode there. Possibly, I don't know. I've got to check that. It depends where if these are inductors or not. So that's where we're at with the design. But like I say, a multi-layer board. It's got ground planes in it, and where the receiver is, well, this Class D amplifiers down here. So, so by putting lower reduced height type inductors in there, seems to, I'll choose my words carefully, remove evidence of any problem happening. But I don't like it. I don't like it because I've been burnt by them. And every time I see a Class D amplifier, anything that's very sensitive, usually makes them noisy. It just does. And people out there tell me these are noisy. But if you put in headphones, the Class D amplifier deactivates. So if you're running it's got a sensing circuit. It senses headphones. Well, it's got a little control circuit. It works on pin 1 and pin 11 on this, and you can use it to sense if headphones are put in. It might even, I'm not sure, it might even measure the overall loading or plug configuration. I haven't gone into it. It doesn't interest me. But yeah, putting those planar type ones in there, bang, that problem seems to have disappeared. Now, I'll give you some measurement from the ones here with those squarey things in there. I think these may be TDK ones. I'm not sure. They look like it, but anyway, I've used them before. I have used them in the past, should I say? Have. I used a loop on my oscilloscope around these devices here whilst the speaker was running and looking at the Class D amplification. And I had at peaking around here with the other devices in there with whatever it came out the factory with. I don't think it comes out the factory with that anymore. Maybe this is probably an old one. But I was getting 50 millivolts peak to peak of noise just around here. And that was quite substantial, really, considering when I put those low profile planar ones in there, it went down to about somewhere between 5 and 10. So it wasn't 50 anymore. It was a massive reduction. So just by putting those in there, and I'd say it does it on the other ones. I've never measured it with the ones that have been replaced by whoever replaces them, service centre or even at Minelab. I don't know. I don't know who does it. But yeah, that's how they cure the problem of running the internal speaker. And yeah, well, it's a surprise to me. I did not know it had a power amplifier in it, and it does. So lucky I went and had a look at the part number and looked it up and worked out what it is. And I'll tell you right now too that when it runs headphones, it reverts back to a couple of AB amplifiers inside the chip as well. It has some low level amplification. The other thing, it's a stereo chip, by the way. So in the headphone mode, I don't know if they're running the two left and right channels 180 degrees out and using that as a differential type line driver, which it lower the noise because that Class D thing, yeah, you don't want to use that on your headphones. The thing is too that as soon as you plug headphones in, the whole thing's quieter anyway. You can just tell it's got a better ambience around it. So, but I'll just go over the computer. I'll take this. If you want to have a look at the chip, I'll show you what the chip is and what I know about it. Like I say, I don't muck around with this sort of stuff, but I gave myself a crash course for about half an hour looking at it, and I think I'm pretty up to speed on it, how it all works. If I can wake the computer up, enter your password. No, I don't want to do that. I'll have to get rid of that. There it is. Oh, that's not it. That's the an LM4871. That's a BTL AB amplifier where it does a phase inversion on this, but it's not switch mode. It's not pulse width modulated. So that's that. We want this one. There's that device I'm talking about. TLV 320 DAC 3100. That's what it is. And when I look at it here, and it said, and mono Class D speaker amplifier, it all rang a bell to me. Because on the circuit board, I'm looking at this DAC, and I'm saying, where's its power amplifier? I couldn't find it. I'm going, it's got to be here somewhere. What are they using? A couple of bipolar transistors or something somewhere on the board. Because it's only a mono output. It's very simple. But then I had a look at it and I went, oh my God, no, that bloody Class D business. So that's what it is. And you can see it's quite a complicated little thing. You can program all your functionality into it. Does your volume control, does your bips, bops, when you push buttons, it does all that stuff. And here's the what I will classify, in my opinion, the offending item, right there. But you can, yeah, there's your disable line, this mic bias line, and there's another line up here. You can actually disable here. It's got that the VDD and where is it? VSS lines here. That they are actually dedicated to the amplifier. I think from memory, because it's in there. I don't think they were put on low level because it'll probably just get back in. So a lot of control lines. That's not the real thing you want to look at anyway. You want to look at down here, and it's a lot of information. That's it there. That's the thing. So there's all your SPKP is one of the pulse width modulated lines, and SPKM is the other one. So it runs those counter phase as well, and just puts it back together at the other end. What else we got here? Analogs in, analog in 1 and 2 there, 14, 13. Vol mic detect is actually can be utilized as speaker headphone detect. That's what the line they use in conjunction with 11 and 1. And here you got various voltage ins, clocks, and all the rest of it. Yeah, so lots of reset line, high pass right, high pass left for the digital stuff. Oh, there it is, all there anyway. What am I bloody trying to decipher it for? It's all written there. So you can go through it, you can find out what does what. Like I say, it's got a I2C control bus clock input and data input there. It's basically a two-line system. You can run it as a 3-line or a 2-line system. I think they run it as a 2-line, like they do in their dongles. Same stuff basically. Where are we? There you go. Like I said, they call it CAS, bad spelling. You meant to put an L in there. It's Class D. Speaker driver, inverting output, non-inverting output, power supply, playground. If you play around with this thing, do not hook up any analog stuff to the digital ground. You'll get buzzing and humming in that if you do that. So I'm just saying, if you want to play with it, lots of specifications there. You can have a look at voltage levels. I think it'll work from 2.7 volts to 5.5 without smoke coming out of it. The higher the voltage, the more efficient and more audio you're going to get out of it. But that's that. So if you want to go and start programming it, though, it gets a little bit more complicated, which I think that it would be a pretty steep learning curve if you've never done anything with digital audio before. And there's all your timing waveforms, your clock and everything else there. So you'd have to go and learn all this bizzo. It generates lots of harmonics because it's a pulse width modulator. It's there you go, generating harmonics all the way up to where? Pretty low level though. They're over 15 kilohertz. You don't want it going into the pass band of the detector though. So, like I say, oh, that's DAC to headphone output, DAC to line output. Where's I want to see. I want to see what happens. Headphone power output. Hang on, I don't want to look at that. I thought they might have one on the Class D speaker driver output. Oh, there it is there. Class D speaker driver output into 4 ohms. Yeah, total harmonic distortion. If you actually invert that round, you'll get a better understanding that they do generate a lot of distortion. They just do it like that, so it looks good. Power output in watts. If you push it hard at 5.5 volts, you can get over 2 watts out of it into 8 ohms. Not bad. You get more if you shove it into a lower ohmage load, of course. But you don't really want to entertain the whole neighbourhood when you go metal detecting, do you? Like half a watt's enough, if you ask me. Depends on the speaker too. But yeah, I want to see their Class D amplifier noise specs. They haven't included it, I don't think. I wonder why. But sorry, I'm feeling a bit cheeky today. I really am, because I'm shocked to see that inside the detector. I'm not saying it's a bad thing. I'm just saying it from my previous experience using Class D devices. So yeah, they only give this stuff that performance. Headphone output, line output. Yeah, they're not going to show any of those graphs. They're just headphone, line. Please show us what comes out the other end of it. I'd love to see a graph of it. I could probably do it. I've got a spectrum analyzer down there. I could actually go and have a look at the spectrum of crud generated, and if you want to look, I can show you down there. It's probably one of the best low frequency spectrum analyzers ever made. It's a Hewlett Packard, very, very, very good low frequency spectrum analyzer. I have got the others up there too, of tracking generators and stuff, but yeah, that doesn't get taken out of there very often, but it's a really nice piece of equipment. And I've redone all the caps and stuff in that too, the power supplies, and it is very, very nice. When they came out, God, the price on those things, my God, it would have been half a house when those things were made back in the day. They're not that old, probably, I don't know, 90s, I don't know. But anyway, on that device there, I think anyone who's interested, if you're, you got big kahunas, you might want to play with it. Otherwise, don't, because if you short it out, you'll be putting another one in there, and as it's a surface mount part, it'll be very difficult to do. So, yeah, there's all the lot of audio specs. There's lots of stuff here. Tells you how it all works up. Yeah, there you go. What's this? The mic bias. I know you can use that for sensing. Tells you about your analog inputs, audio DAC, audio analog outputs. Yeah, you can go read all this stuff up if you want. Not that it's entertaining. It's pretty dry, isn't it? But you can go look it all up if you want to play with it. And yeah, it's basically block diagrams on how things work. But like I say, it's a lot of stuff to learn just to do one device, unless you're going to use it in other devices. I hope not. I just hope not. For my sake. You got to remember this. Okay, well, just look at it this way, right? We know, like, even when I did say, oh, the battery's going to last forever. It's going to be very efficient, whatever, right? But when you think about it, you don't need a lot of wattage driving a speaker in a metal detector. You get away with easy half a watt, easy. And when you think about it, you go from class A, B to class D, you're talking probably 20 or 30 milliamps or something difference. It's not a deal breaker in the way of the battery life. It's not going to have much of an effect. But I suppose if you're doing a design and you've got a mindset, you'll do everything to conserve battery energy and extend the life of, or the operational life of the detector between charges. But Oh, at what cost? But anyway, that's that. That's all about this feedbacky bizzo. So now we know why, because it's got a big blasting Class D amplifier in that chip, which is utilised on the internal speaker. So that's just telling the truth, just the truth of what it is. My experience with Class D. Yeah. Now, there's a few other things we're going to look at in this detector, but like I say, I'm going to shut up because what happened last time, I just started basically explaining everything I'm going to do to this, and then I realised at the end of the video, what the bloody hell are you doing? You know, it's not just I've got to realise that there's competing forces out there who will siphon up all this information, and some of it I just can't go and blast out there. I know a lot of guys, you know, the ones that I talk to on and off the YouTube, want to know certain things about the detectors because they've got problems. And I just can't make videos about it and go, oh well, you know, this is causing that and that's doing that, and you know, I just can't do it because you know, I can't say it in the way I want to say it because it involves swearing, and then the videos will disappear off YouTube or something. I don't know, or I've got to start putting I've got to load it up as over 18 content where there's a lot of people who want to go detecting who are you know, younger than 18. So yeah, I don't do it. Well, I can't do it. That's very interesting, don't you think? How that's panned out. But that's what it is. That's a story. But I feel like such an idiot when I was looking at it. Now I'm looking for the amplifier, and I'm hunting all over the board. I'm going, where have they hidden the audio amp? And then this doesn't make sense. What's going on here? And why does that chip need those two big inductors? And then I actually poked it and I saw the pulse width modulation, and I've gone, you got to be joking. No. And then I looked up the spec on the chip and it was. So yeah, quite interesting indeed. Because when I was looking at it with a loop, I wasn't actually probing it with a probe. I had it set at some high frequency. I was just looking at the overall noise. I didn't know it was pulse width modulated audio. You know, packet blocks of audio everywhere. It was just a big mess on the screen going blah blah blah. So I just thought, you know, well, why is that doing that? And is it part of a power supply there or something? I never twigged it was a Class D amplifier because I'd scared myself away from using them for this sort of stuff where anything's sensitive, and I just thought no one else would do it. So I was wrong. Other people do it. So, but like I say, neither here, neither there. It did you know, bring up an issue with this design when it was first made. And you know, you can't hide that, you can't deny it. It's bloody obvious. Everyone knew it. And yeah, anyway, now they fixed it, put lower profile inductors in there, and it does. How do we say? It gets rid of the obvious. Gets rid of the obvious, which is the noise. Okay, leave it there. But there's a lot more to do with these detectors. You got to remember a lot of this stuff. If I was making detectors, you know, would I want to get to market really, really quick, or would I, you know, keep the engineers on it and say, "Oh, refine it, refine it, refine it, refine it," or would you be listening to the bean counters saying, "Come on, get it out there"? You know, we're losing money. That's how it works in real life. That's how it works. You know, you'll have competing interests, and there is a saying out there which is when something's being developed and it's developed to a point and the engineers still want to work on it, well, there's this thing you say, well, look, it's time to shoot the engineer, which means get him off the case and just get the thing done, get it out there. And that's true. That's a true saying. Shoot the engineer. That's what the bean counters will say. Get him off it, because you can just keep testing, research, refine, test, more research, check, check, check. Is this talking to that, that talking to this? If I fix that, does that do something there? Can I now get the noise down over here because that's less there? It goes on and on and on. So, like me, I'm waffling. Anyway, that's probably enough. This video I will put up because I haven't gone too deep, too far into things, and it is what it is. Okay. So anyway, I hope you enjoy that. If you enjoy it, give it a thumbs up. If you never want me to do it ever again, give it a thumbs down. Uh, hey, I don't make money out of doing these videos. There's nothing in it, right? It's minuscule. I think when I first started, I'm waffling, okay, but when I first started doing it, I think it's making about, the videos would make something like maybe, I don't know, $15 a week or something. And I said, bugger that. There's no money in it. You can't do it for money unless you start really getting, 50,000 views in a day. That's when the guys make money out of doing this stuff. Otherwise, you're just doing it for educational purposes. That's all it is, just educational purposes. And, it stops me doing real work. And, well, the thing is that previous to the video, I've done a lot of research, and I just thought, why not put it out there a little bit? Probably there's parties out there just like me to keep my mouth shut and never say a thing about it, but it is what it is. It's there. It's not secretive or anything. All the secrets are in there. So the land of secrets. Anyway, enough carry on, enough waffle. So that'll be that. Next time you'll see this, I will have done many, many, many things to it. And yeah, there will be many, many things done to it. And then we'll go and see if we can quickly get out there and do some field tests with it. And I hope another one comes in the meantime, so I can compare one standard and one not. And hopefully it's got those big inductors, and I can show you it screaming its Menorcas off, right? So if it has, I would have done it with this, but I just wanted to get rid of those things off there and get it done. So that's what it is. Yeah. I can't really think of anything else to say about that. We had all speculation of what was causing the problem. Was it the speaker voice coil generating, electromagnetic field back into this, getting picked up by those inductors, or what? No. It's nothing to do with that. It's a bit more on the board rather than off on the speaker. But the end result was the speaker going bonkers because a feedback loop. So I really doubt it was the speaker doing it. It's basically those devices that were there were those that were somehow getting back into the electronics. But anyway, neither here, neither there. Funny how these things go out the door like that. Probably never get tested. I don't know. No, I'm joking. Come on, I know you test every detector that you make. But yeah, if it's made overseas too, you can't control who does what where it's being made. But anyway, won't say too much. I'm just having a muck around joke, loose opinions. I don't know factually anything about this thing, how it got made. I've got no idea. I don't know who designed it. No idea. Why it's laid out a particular way. No idea. But I do, sort of, but I don't. Anyway, I'm carrying on. Anyway, catches.